So if the mass of one object is doubled and the distance is doubled, what happens to the gravitational force? So gravitational force, equations are on the back, is this equation. If I were to double one of the masses, that would be a 2m, and double the distance, r gets squared, so that would be like a 2 over 4, which is just 1/2. And you can put it in your calculator, and if you get the 2 over 4, just hit math, enter, enter to simplify it a little bit. And then that means I get half the force. So field force is F, my new force is half that. Planets A, B, and C are identical. They have, these two are giant moons. This is a lightweight, which is the strongest gravitational interaction, so I meant to put force there. Basically, if we're looking at this equations, to get a big force, you want big mass and small distance. So the one that has a big mass and small distance is A, because it's big mass and close. 6 times the mass, twice the radius. What is the acceleration due to gravity? So 6m over twice the radius. That's going to be 6 over 4. So that's how many times bigger the acceleration due to gravity is compared back to Earth. Earth's is 9.8 times 6/4. And when you multiply that, you get the 14.7. Two planets have the same acceleration. One has 4 times the mass, and we're looking for how the radius compares. So 4 times the mass, looking for what happened to r, and I want to end up with the same, so that would be like times 1. So if I have a 4 on top, that means I'd have to have a 4 on bottom to get to 1, which means I'd need a 2 right here, because that's going to get squared to give me the 4, so twice the r. What would happen to make the new force 4 times as much? So GMM over blank r squared gives me times 4. If I were to double the distance, that would get squared and give me a 4, but it would be 1/4, so that's incorrect. If I were to half the distance, that would be 1 over 1/2 squared. Put that in your calculator, check, that does give me 4. Quadruple the distance would be 1/16, and 4 1/4 would be times 16, so the 4s wouldn't be getting squared. We've got an orbital radius, we've got an orbital period, we're looking for the mass. So if we look at our equations, I have T and R, which means I can use this equation to get V, and then once I have V, I can use this equation to get the mass. Plug in. Our unknown is on the bottom, so the first thing we want to do is multiply that up. Now it's on the other side. And then we're trying to get V by itself, so I'm going to divide this number over. That gives me my velocity is 2138. And then now I'm going to use my V equals square root of GM over R equation. I'm going to rearrange first, just because these are kind of nasty numbers to be squaring and multiplying and dividing around. So I'm going to rearrange right now. I have a square root I need to get rid of, so I'm going to square everything. That gives me V squared. And the square and the square root cancel out and just leave me with what's inside. To get n by itself, I would need to multiply the r up. And I would need to divide the g over. So then this is what your mass is. So now we plug in. Radius times velocity squared over g, which is the 6.7 e negative 11. And now you just type that in your calculator. You should be getting 6.4 e23. Net force on the center object, so A, B, C. Here we're looking at the forces on B. So that would be the force of A on B and the force of B on C. Your equation is the KQ over R squared, where K is that constant, 99, Q is the 2 charges, and R is the distance between them. So we've got 99 times 6 times 6 over 0.1 squared, and 99 times 6 times 9 over 0.15 squared. And you'll notice I did not use the negatives, because the negatives just tell me about retract and repel, which I'm going to know with my arrows, so it's a lot less confusing to not put those in. So then for AB we get 3.24 E13, and BC we get 2.16 E13. BC, AB. And now we need to decide, so the net force If they're in the same direction, we add, opposite directions, we subtract. So let's look. A and B are attracting, which means they go towards each other. So A, B like this. B and C are also attracting because they're opposite signs. So they go towards each other like this. Now looking at the net force here, two forces, opposite directions. I'm going to actually subtract them. AB is the bigger force. So that means I'm going to end up with my net force to the left. So I just do the AB minus the BC. So this minus this gives me a net force of 1.08, E13 newtons to the left. All right, we've got three metal spheres, X, Y, and Z. Y has +1, Z has -4, and X is neutral, which is a total charge of 0. Y and Z are touched, so when they touch, they have the total charge is basically balanced out or split evenly. So these two have a charge of -3, and then that would split up, so each would get -1.5, and then X would stay the same, so nothing happened to it. And then X and Y are then touched, so the -1.5 total is going to be split between them, so it'd be -0.75, -0.75, and then this one just gets dropped out. So the charge on X is -0.75, and then these are the other two. Electrical force is KQ over R squared. So if we want to decrease the force, that means we want less charge and more R. So less charge and bigger distance, C. If the cone becomes negative, that means that the cone gains electrons. That means that the hair must have lost electrons. Protons are not moving. So the hair loses electrons to the cone, C. I've got a charge, I've got a force, I've got a distance, I'm looking for the other. So F equals KQQ over R squared. 5.1 equals 9E9 times 8.4 E -4 charge over 4 squared. 4 squared is just 16. I'm going to multiply that 16 up. That becomes 81.6. Multiply these together, that's 75, 6 with a bunch of zeros. And then now I just divide over. And that's what's going to give me the 1.07, e to the -5. Now the sign, our equation does not give us the sign. We have to read that this is an attractive force. We know opposites attract, so if this one is positive, the other one is opposite, which is -B. We want a neutral electroscope, so the electroscope is this part, that's negative, nope. This is all positive, nope. This is neutral, but if I bring a positively charged rod, all the electrons are going to move up to the top and leave this positive and this negative, so D. +4, +6, this is a rod, this is a sphere. When they touch, afterwards, they will share the charge, so that's a total of 10, so they each have 5. You'll see that so this one became more positive than before, that means it lost electrons. This one must have gained electrons. So that means they're going this way, lose, gain. The sphere gains electrons, yes. From the sphere to the rod, no. Rod loses, yes. Protons, no. And the sphere becomes negative, no. We gain 1 electron, so it's not as positive as before, but it's not negative. Distance between the second and the third in order for the first to be in equilibrium. So as soon as you see equilibrium, you should set the forces equal to each other. I want the first object in equilibrium, so that would be AB and AC. And now we plug in K, A, B is 10 over 2.8 squared equals K. A is 8 times 16 over, I'm going to call it X squared. But notice this is going to be the distance from A to C. So that's like my X. Cancel out the K's, the 8's, and now we cross multiply. So 10x squared equals 2.8 times 16. 2.8 squared times 16 is 125. Divide the 10 over. And take the square root, because that's x squared that's equal to 12.544. That gives me an x is 3.54. And then now that I know that, careful, because I actually want this distance right here. if from here to here is 3.54, to go from here to here, I would just subtract, and that would give me 0.7. So obviously this diagram is not to scale. Alright, highest total current. So if I want the most current, so most I is going to be the least resistance, because current is the flow of electrons, so the least resisting, then more can flow. So then now I just need to find out what all of these R totals are. So 3 resistors in parallel, that's going to be the 1/2 plus 1/2 plus 1/2, 1 over that, and then plus this 2 on the outside. So for this one, I got our total was 2.67. This one is just 6, and then 1/6 and 1/2. And don't forget to 1 over at the end. That gives me an R total of 1.5. Here it's just 1/2 plus 1/2 plus 1/2 plus 1/2, 1 over at the end. That gives me an R total of 0.5. Here you've got the 1/2 plus 1/2, 1 over that. So that gives me 1. And then this one, so this has an R total of 2. The one that has the most current has the least resistance. Least total resistance is D. Looking for total resistance of the circuit, so I need to combine these two. They're in parallel, 1/1 plus 1/1, and 1 over that, so that becomes 1/2, which is 0.5. 0.5 plus the 2 is an R total of 2.5. Total current, V equals IR. Total voltage is the 12 volts. Looking for I. Total resistance is 2.5. Divide over, you get 4.8. Voltage used by this, so the total current is 2.5 amps. So now I'm just V equals IR. 2.5 times 2 gives me, ooh, it's not 2.5. It's 4.8, my bad. The current, not the resistance, so the current is 4.8 times 2, which is 9.6. Finding the current through this guy, so V equals IR, the only voltage I have is the battery, the total voltage, which means I have to use the total resistance, so R total would be the 8 plus the 16, which is 24. And then divide over, we get 0.75. This is a series circuit, so they both get the 0.75 amps, and the voltage drop here would be V equals IR, 0.75 times 8, which is 6. Resistance of the missing R, so V equals IR, voltage is the total voltage, so it'll get me out my total resistance, 120 equals 0.5 R total. R total is 240. That's the total resistance and not necessarily my missing. In fact, I have a 50 already, so I'm going to subtract the 50. 190 is what would give me an R total of 240. So the missing resistance, oops, I circled the wrong one. Missing resistance is 190, not the total. Which of the following would be how to decrease the current? So V equals IR. If I divide the I over, divide over to get I by itself, I is V over R. So if I want less current, I want less voltage and more resistance. So increase the resistance and decrease the voltage. What is the reading on this current? So this is a parallel, so voltage is the same. I'm looking at this guy, so V equals IR, 12 equals I20, divide over, you get 0.6. And voltage drop is 12, because it's parallel. What is the current in the first resistor? Well, they all have the same current, so I'm going to find the total current, because I have the total voltage. Total resistance is 24. Divide over the 24, not the 12, because you want to cross off, and that gives me 0.5. Here, V equals IR, I want the total voltage because I have total current, I have to use total resistance, so 1/6 plus 1/6, 1 over that gives me a total, R total is 3, and now we plug in, total current is 2 times total resistance, it gives me 6 volts. Here, this is momentum, so we're talking about a collision, so I've got my M1V1 plus M2V2 equals M1V1 plus M2V2. Before picture's already there, so 3 times 8 plus 2 times, now careful, direction matters, this is going to the left, you better put a negative sign, equals, and then your after picture is that they stick together, so then that would be 3V plus 2V. I I don't know what the V is, that's what I'm looking for. Now we just simplify, that's 5V. This is negative 12, 24 plus negative 12, which is positive 12 equals 5V. Divide the 5 over, and you get 2.5. I know it's going to the right because it's a positive number. If I get out a negative, that means to the left. Moving forward at a constant speed, so this is a distance graph, so I want a straight line and going up, so here and here. This is at rest. This is going backwards, so 0 to 20 and 40 to 60, C. I've got a mass, I've got an applied force, and I've got a friction force. What's the acceleration? So if I have an applied force of 100, friction goes against, so then I can get my net force. I would just subtract because they're in opposite directions. 80 equals mass of 12A, and then we just divide over. You get the acceleration of 6.67. W is the maximum potential and the minimum kinetic. Here, this is the minimum potential and the maximum kinetic. I know it's the maximum potential because it has the most height, and minimum potential because it has the least height, and then the total energy stays the same, so maximum potential would be the opposite for kinetic. So then D is the correct one. As the pendulum swings from A to B, which is following is true, well, we know total energy remains constant, so I'm really between just A and C. And my gravitational potential energy is actually increasing because your height is increasing on the way up. Kinetic is decreasing. Yes, it should be getting slower on the way up because it's going to potential. Rest of a 20-meter high hill. What is the speed of 5-meter high later on? So I like to draw my picture. Kinetic and potential. The only zero would be starting from rest. Now to find the potential, I do MGH, so that's 300 times 9.8 times height of 20. And that gives me a potential energy of 58,800. And then I can do the same thing for later on at the 5-meter high hill. That gives me 14,700. Now I want to find this kinetic energy. I know that my total energy is the 58,800. So then all I have to do is subtract from my total. So I subtract this minus that, and I get 4,410 or 4,400 for my kinetic. And now I can plug in and get my velocity. Half of 300 is 150. Divide the 150 over. Still not done because the 294 is v squared, so I would take the square root and I'd get velocity of 17 point something. Alright, when it is at rest is when your kinetic energy is 0, so it should be all potential. So where your potential, that is at point A. When it is moving the fastest, that means you have the most kinetic, which would be when you have the least potential. So when potential energy is 0, that's point C. Skier starts from rest at the top of the mountain. At the bottom, it has a velocity of 25, so that would be potential is 0, kinetic use the 25. I don't have a mass, but I'm just looking for the original height, so mass will cancel out in the end, so I'm going to use m equals 1. Kinetic is 1/2 mv squared. That gives me a kinetic energy of 312.5. If I started from rest, then your kinetic would be 0 here, so my potential would just be the total, which is the 312.5. Potential equals mgh. 312.5 equals 1 times g times h. Divide the 9.8 over, you get a height of 31.8. Starting from rest at point A, so that would be kinetic is 0, all potential. At C, I've got both. I have a height of 25, so I'm going to do mgh of 25 for my potential. That gives me a potential of 3675. But I also have a velocity, so I'm going to do the kinetic energy, 1/2 mv squared. And that gives me kinetic energy of 750. these two combine to get my total. So my total energy is the 4425, which means at the top, if the kinetic is 0, then my potential is just my total. And now we plug in to get our height. You get a height of 30.1. Skateboarder has a mass of 30, final velocity of 7, work is 360. What was the initial velocity? So I'm going to use, I have 3 work equations here. I'm talking about velocity, so I'm going to use the change in kinetic energy. Change means final minus initial, and kinetic energy is just 1/2 mv squared. So it's 1/2 mv squared minus 1/2 mv squared. Make sure you do final minus initial, and now we plug in. 360 equals 1/2 mass of 30, final velocity 7 squared minus 1/2 mass of 30 vi squared. This, I'm just going to simplify, that is just 735. That's 15 v squared. And then now algebra. I cannot combine these because this has a v, this one does not. So what I'm going to do is subtract this over. That just becomes, what does that become? Negative 375 equals negative 15v squared. Divide the negative 15 over. That gives me 25 is v squared. Take the square root. You get velocity is 5 meters per second. Work done to lift a mass, initial height to final height. So still using my work equation, but now it's changing potential energy. So that's PE final minus PE initial, which is mg final height minus mg initial height, and you type it in, you get your work is 492 joules. Same pitch, so I don't want it getting more squished together or less squished together. I want the spread outness to be the same. And quieter has to do with the amplitude or the height, so I want to get less amplitude, less height. So see how this gets less height? That's our one. It's equally spaced out, so it's the same pitch, but I am losing amplitude, which is losing volume. This is a typo. I did not need to have the hertz there. So if the period is 0.33, so period is 0.33, that means frequency is 1 over the period, so 1 over 0.33, which is 3. So V equals F wavelength, frequency is 3, wavelength would be not the 6 meters, because that's for 1, 2, 3 waves, so then wavelength would just be 2 meters, and that gives me a velocity of 6. Right, shortest wavelength, so A is this long, B is also that long, C takes the whole thing, and D also takes the whole thing. So the shortest wavelength is the one that does not take as much length. That is both A and B. Quietest has to do with amplitude, so the least amplitude, the least tall one is B. The lowest frequency, low frequency is really spread out, long wavelengths, so that would be C and D both. Period is 5 seconds, so frequency is 1 over 5, which is 0.2. Got ahead of myself there, but amplitude is equilibrium up, so that would be 2 centimeters. Wavelength is the length of the wave, so from 0 to 2. Speed is V equals F wavelength. We already have the frequency is 0.2 and the wavelength is 2, so speed is 0.4. These two, for sure the pitch is different. This is a high pitch because it has a high frequency, and this is a lower pitch. So wave A is lower pitched for sure. These look about the same height, so I can't really tell if one is quieter or louder, so I'm just going to leave it like that. If one was significantly taller, it would be louder, but I don't think you can really tell there. They look about the same height. Alright, so speed is 10. What is the frequency? So B equals F wavelength. 10 equals frequency. I just need to know my wavelength. 4 is not the wavelength because that's for 1, 2 waves. So then wavelength would be 4 meters for 2. That's 2 meters for 1 wave. Divide over, that gives me a frequency of 5. So this is 8 meters right here. I've got a speed, what is the frequency? So V equals F wavelength, frequency, or speed is 1.33, looking for frequency. 8 is not your wavelength, because that's for 1.5 waves, so wavelength would be 8 meters divided by 1.5. That gives me a wavelength of 5.33. And then to get frequency by itself, we just divide over, you get a frequency of 0.25. High pitch means high frequency. Big frequency means small period and small wavelength. I should have the same speed for both, and it doesn't affect the amplitude, right? I don't know if I have a big amplitude or a small amplitude, but the frequency doesn't change it. So I have a big frequency and I have a small period and wavelength, so your answer is C, big frequency, small wavelength.